Okay, what I want to do today is give you an example on how to use the scientific method as we've discussed in class, from step one all the way down to the final step. So, the first thing you need, as I've said in class, is that you need to have a problem. We need to have a purpose. So, here, the example I'm going to use today is what effect does smoking cigarettes have on your chances of getting lung cancer? So, there's the problem. So, now the next thing we have to do is we have to go to step two, research. Here, we make some observations. We use prior knowledge, possibly about cigarette smoking and everything that we've learned over the course of our life about some of the harmful effects of it. Maybe you know people who smoke. So maybe during this time, you're interviewing people, you're asking questions, making observations. Once you've gathered your information, you then form a hypothesis. Now, if you remember in class, I had said that to correctly form a hypothesis, we use an if-then statement. So here, my hypothesis would be, to answer the problem above, would be if I smoke cigarettes, then my chances of getting lung cancer will increase. Perfectly stated hypothesis. It is an if-then format, which will now allow us to then set up an experiment to test our hypothesis. Now, when we test our hypothesis, we have to set up an experiment that's relative to the hypothesis above. But first, what I like to do is identify the different variables that we are working with in the experiment. So the first, what is the independent variable? Remember, the independent variable is the factor that we are testing. So what is it that we're testing here in this experiment? Well, we're testing, all right, cigarette smoking. Okay, so smoking cigarettes is our independent variable. The dependent variable is what we're measuring. So here, what are we measuring? We are measuring the risk of getting lung cancer. Okay, so the risk of getting lung cancer. All right, and usually those variables are right in the problem. Smoking cigarettes, getting lung cancer. Independent variable, dependent variable. Okay, so remember, the independent variable is the factor you're testing. And the dependent variable is what you're measuring. All right, so once I've identified the variables, now I can set up my experiments. Now, during class, we talked about two different groups. We have a control group and we have an experimental group. And then we also want to identify some constants that are in both groups, all right, in order to get accurate and valid results. So in my experimental group, this is going to be a group of people that are the ones that are smoking. Okay, so these are the people who are the smokers. Remember, the experimental group contains the independent variable. All right, always. The independent variable is always in the experimental group. Now, the control group is something that we compare. So if I want to see whether or not smoking has any effect on lung cancer, all right, great, I got this group, but now I need something to compare to. So over here, I'm going to have a group of people that are the non-smokers that we will monitor over the course of, say, a 10-year period. So this is going to be over a 10-year period experiment. I know it seems like a long time, but when companies like this do research, 10 years, for humans on an experiment like this is is minimum. They might even make it even longer, but for our purpose, we're going to say 10 years. All right, so I have my two groups of people. One is the non-smokers, one are the group of smokers. So that's going to be the only difference between the two groups, is the one that has the variable that we're testing. So now both of these groups are going to have a lot of similarities. So for example, they're both going to be monitored for non-smoking for 10 years. They're both going to be, in this group, they're going to be smoking for 10 years. Another constant might be the age group should be the same. All right, so if I'm going to have a group of, let's say, we'll say 20 to 30 year olds, well, over here in this group, I should also have 20 to 30 year olds. I don't want to test a group of 70 to 80 year olds and a group of 20 to 30 year olds. That just wouldn't be accurate or valid. So we want them to be the same age. We could even say, the same gender. Maybe we're testing the effects of lung cancer on men or women. So if I'm going to do an experiment with men, then I want to make sure I have men in both groups. If I'm doing it with women, then I want to make sure that I have my control group with all women and my experimental group with all women as well. So you could set it up both ways, or maybe you do a mix. Maybe you do 10 women, 10 men in each group. All right. So again, we want it to be constant. Another constant, maybe they live in the same area. What I mean by this is, maybe we're going to take this sample of people from New York City. So I want to make sure that the non-smokers live in New York City with the smokers who live in New York City. Again, environment, exposure to certain pollutions and atmospheric stuff should be the same. Okay, I'm not going to have one group in a highly polluted area and then one group in a rural area where there's zero pollution. So I want to keep it as accurate and the same as possible. All right. Let's see if we can come up with one more. Maybe the same brand. All right. For I know it's not for the non-smokers, but for the smokers, all right, they should be smoking the same brand of cigarettes. All right. I think that would be a constant within their group. But for the most part, both of these groups, all right, being recorded for the same amount of time. Their age group should be around the same genders, live in the same areas, all right, things like that. So some constants. All right, so now let's fast forward to 10 years from now. Okay, and again, if you need to, you can always stop and pause, all right, to record or to take notes or to go back and listen. All right, so we're fast forwarding now, 10 years. All right, so we are in the year 2030. All right, let's say, because we're in 2020. So now we fast forwarded 10 years, 2030. I bring these people back in and I look at my control group. And what I find out is that 5 out of the 20 got lung cancer. Now remember, these were the non-smokers. All right, but just because you don't smoke doesn't mean you can't get lung cancer. A lot of other factors can contribute to it. But based on this group, 5 out of the 20 got it. Okay, 5 out of 20, that's 25%. So 25% of this group got lung cancer. In my experimental group, the smokers, my results were 10 out of 20 got lung cancer. So that's 50%. All right, and again, these results were recorded after a 10-year period. Now, a while back, I had mentioned that there were 2 types of data, quantitative and qualitative. All right, so when you look at these particular results, because we're dealing with numerical data, all right, and percentages, 5 out of 20, 10 out of 20, 25%, 50%, this is quantitative, okay, quantity. Okay. So looking at this data now, I see that 50% of the smokers got lung cancer, 25% of the non-smokers did. So in my conclusion, based on the results of my experiment, I think we can conclude that smoking can increase your chances of getting lung cancer. Based on these results. And we have to say that based on these results, because somebody else could take it, could set up a similar experiment and maybe get different results. So this would just be what my findings would be. All right. And then I can add to this and say that my hypothesis was proven correct according to the data presented. So because my hypothesis was proven to be correct, I don't need to retest. So this is how we use the scientific method, all right, to solve any particular problem. So just to kind of recap real quick, we had the problem. What effects does smoking cigarettes have on your chances of getting lung cancer? Some of our observations that we made, or some of the research that we did, was making observations and understanding some prior knowledge about cigarette smoking. We formed our hypothesis. If I smoke cigarettes, then my chances of getting lung cancer will increase. Then we tested our hypothesis. We set them up into two groups, non-smokers and smokers. All right. We kind of set up the two groups as similar as possible with some constants in here. 10-year period or age group should be about the same gender, live in the same area. All right. Things like that. And then after 10 years, we recorded our results and we found that 50% of the smokers got lung cancer and only 25% of the non-smokers did, which led us to our conclusion that smoking can definitely increase your chances of getting lung cancer.